We're really excited to have Chip Kramlich, who's going to teach you a lot about this course and all the awesome things you can do in your class with Arduinos. We are going to get started in just a bit, but we want to know who is here so we can understand your understanding already of physical computing, your background with Arduino or CodeHS. So Chip, if we could go to the next slide. Everyone, if you can hop into the chat, I know you might have to find the chat box. That will be a good thing to keep open, as we're going to give you a lot of links and helpful things in the chat today. But if you can do a little intro, let us know, what do you teach? Have you used CodeHS before? I know we get a lot of people who are brand new to CodeHS and people who have been using it for years and are just looking at new courses. So let us know, have you taught any physical computing courses, and have you used Arduino before? Or are you just interested in learning about something new? So if you could throw that into the chat, that would be awesome. We want to know who's here. And we are also joined by two of our other PD specialists at CodeHS. So we have Joni and Lindsay, who are going to be here helping us out. You're going to hear from Joni later when we talk about different CodeHS specific tools and customization. Lindsay's going to be helping us with all our questions that you have, and making sure everything runs smoothly, giving you links as we go through. Awesome. Marilyn, teaching Python, cool. No experience with Arduino, but you got one and you want to learn how to use it. Awesome. That is great. And you have used CodeHS. Cool. That is awesome to know. We have, I know we had some people asking, do I need to have an Arduino before I come to this session? And the answer is no. But if you already do, you're going to get real excited and you're just going to want to start doing it right away. Awesome. Teaching several CodeHS classes. Awesome. Already have a class set of Arduinos. Ooh, you're lucky. Never taught physical computing, but want to use it. Perfect. Yeah, this is great. First time with CodeHS, but have some experience with Arduino. Oh, taught with microbits. So we have a course with microbit as well. Hopefully you can check those out and take a look at the difference between those. Awesome. No experience though with Arduino or CodeHS. Using CodeHS, but new to physical computing. Awesome. We have a great mix here. Cybersecurity. Ooh, renewable energy. Yes, we need you. Awesome. Web development, but just starting to use CodeHS. Wow, we have a lot of different experience levels, both with CodeHS and with Arduino and with physical computing. So this is going to be great. We are going to get started in just a bit. We're going to wait maybe one more minute to make sure everyone can get in. But just a reminder, you are going to get links throughout our session today in the chat. So make sure you keep that open. We are going to give you the slide deck in just a second. I know you're ready. Awesome. Arduinos to 8th graders. That is great. That is so awesome. What a good start for them. All right. So we are going to hop in with Christine, our link to our slides. So here you go. We have a QR code that we're going to pop onto the screen that you can use to get the slides quickly, or you can use the link in the chat that Lindsay just popped in there to get to the slides. So if you want to have the slides open and go through, follow us along, there are clickable links right in the slide. So that might be an easy way for you to access the information as we go. Or if you just want to keep the slides open on the side so that you can revisit them later, that is totally fine as well. This is for you. All right, we also have a question parking lot, because we don't want your questions to get lost in chat, because you'll see chat will kind of, get a little bit crazy at times. So this question parking lot, this is, I would say, the most important thing to have open on the side. At the top of the question parking lot, there's a lot of links to everything. So even if you missed that slides link, it's right at the top. You have all of the links that we're gonna provide you today throughout our session are on there already. And then you have sections to add your questions so that we make sure we answer every question. We don't want you to throw something in chat and it not to get seen or answered. So we are gonna put all of the answers in there. If you don't even have your own questions, but you just wanna know what everyone else is asking, there is, that's a great thing to have up, and we're gonna throw in a lot of links there to articles that will help you. So that's a really good resource to have available as we go through our session today. So as we're going through, at any point, throw your questions in there and we will make sure that we get them answered by the end of today's session. And if you ask a question that we think needs to get, moved up and asked to the whole group, we will definitely do that as well. So keep an eye on that. All right, let's look at what our agenda is going to be for today. So we're going to start out, we started out just finding out who's here, doing a little check-in. Oh, can everyone else hear my audio? Just want to make sure. Kurt said he was having some trouble. All right, Kurt, maybe hop out and you can hop right back in. That might help. Let us know in the parking lot if you're still having trouble and we can troubleshoot that. We are going to look at the Arduino course as a whole. What is in it? How is it taught? This course, I saw some of you have used CodeHS before. This course is very different from our other CodeHS courses. So it's really, we're gonna go over all of those differences in this course and the things that you wanna be mindful of before you start teaching this course. And then Chip is gonna go into a full sample lesson with Arduino. So he's gonna run through, as if you were students, what are they going to experience if they're in this course? We're going to look at an investigation of those modules, and that's an exploration into what those entail. And then towards the end of our session, we're going to do a breakout where you're going to have the option, because I know a lot of you, I've seen your names at a bunch of our workshops. So if you have specific questions about this course or questions for Chip, experiences that he's had in the classroom, anything with his experience working with Arduino, that's going to be an awesome time for you to hop into our breakout room and ask him some individualized questions. And then if you are brand new to CodeHS and you're like, well, I'm just overwhelmed, I don't even know how to get started, Joni is going to lead us through a session, how to make your own sections, how to customize the course, because we know every classroom's different. So she's going to go over a lot of cool and helpful tools for you to use as you're using our CodeHS course today. And at the end, we'll do a quick Q&A, anything that hasn't gotten answered in the chat or any last thoughts, and we'll wrap it up. All right. Hopefully everyone is good with their audio now, and we're ready to roll. So if you have a CodeHS account already, I want you to go ahead and just log in. If you don't have an account, if you're brand new, you can go to this link, codehs.com/sign up, and it will ask you just a few quick questions. Make sure you note that you're a teacher on there, because there are things that are available to teachers that clearly are not available to students. So that you will go through a little verification process, but you should be all set to access all of the materials for today. All of our content is free. So all of our curriculum, all of our courses is free for you. Once you're in there as a teacher, you can see all of that. So you'll have access to the Arduino course for today, but you can also take a look at what other options we have. So once you get your account, we are going to enroll in our Arduino section. So you have access to the materials that Chip is going to use. So Lindsay already dropped in the link. Chip, if we could go to the next one, it will just let us know this is our workshop section. And this is actually how students join a course, your course, when they're in your classroom. So you're going to give them a link similar to this. If it asks you for a code, the code is just those last 5 digits. So BFFA1. And this is how you are going to join the section as a student. So you're not going to have teacher access to this section, but you can create your own section. And that's what Joni is going to teach you how to do at the end, if this is something that you're interested in getting all the teacher information on. So I know I've just whirlwind at you. So the last thing that we need to do before we're going to turn it over to Chip is to put our attendance in. So you do need to have your CodeHS account before you can record your attendance. It's linked to your account. So make sure that you have your sign in, you're already in CodeHS, and then you can go to this attendance link. It is dropped in the chat as well, codehs.com/Arduino attend. And this will just record that you are here today. If you are having any trouble with any of those steps, I know it was a lot of to do, throw it in the parking lot and we will help you out. We have lots of support ready to help you if there's any issues. All right. So I'm going to wait just a minute so that everyone can catch their breath, and then we'll throw it over to Chip. All right, so again, what you want to have open is definitely that question parking lot. Any issues that you have throughout the session, anything that comes up, just make sure you put that in the question parking lot and we will be on it to help you out. We're going to throw it over to Chip, who has been working with Arduino for more than 15 years. So he has a lot of experience with this, and he knows the physical computing course with Arduino on CodeHS inside and out. So he's going to tell us a lot about that course and his experiences. All right, take it away, Chip.
Well, welcome everybody. Again, Chip Kramlich. I teach at Fayette County High School in just south of Atlanta. I've been working with the Arduinos as a hobby, and then started teaching it I started teaching about 6 or 7 years ago when I wrote my own materials for that. The great thing about working with physical computing, again, it's that hands-on experience. Kids just aren't writing code on the screen and having it do it. They actually get to actually build something with their hands, write the code, and watch it actually work. And again, that's where, if you're doing this kind of stuff, it's getting those students more engaged, and they will actually enjoy it quite a bit. Now, this is a 1-semester course. It's designed more for high school, and that's mostly due to the C++ programming language that the Arduino is programmed with. Now, there are some advancements. We don't have a course for it in CodeHS, but if you do want to do more with physical computing, I would recommend looking at something called Circuit Python. It doesn't work on the actual Arduinos, but some of the newer boards that have come out that are like Arduinos, it works fine, and those can actually be done at a middle school level. Okay. So this course is definitely an interactive course. Again, students are building circuits, and that's the great thing. And then they're electronically controlling these through software with this device called an Arduino. Now, our Arduino is a little different than a regular computer. This is what's called a microcontroller. Microcontrollers don't really have an operating system, so they only run one program. So whatever that program is, they're just running it constantly. So a lot of these devices, these microcontrollers, are part of what's called IoT, the Internet of Things. They are the computers that are helping to monitor devices in your car. They are the smart devices you have in your home, whether that's like an Alexa speaker or a smart refrigerator. They all have things like this Arduino inside of them. So this is definitely something that is focused for a career pathway, if your school does do pathways, for something where they want to mix that hardware and software together. Now, with this, students are going to have to do two things. One, they're going to have to actually wire up the circuit, and they're actually going to have to program it. The good thing is there's actually a simulator. So instead of you just automatically throwing your students directly into hardware, they can actually practice it out in the simulator first, wire up the circuit, write the code, and then once they have that, they can then have the circuit they can actually look at and try it out in real life. Now, software we're going to be doing are two things. There's the Arduino IDE. This is a downloadable product that you can install on your computer. There is a web version of this that Arduino offers. It has limitations unlike the downloadable software, and there's also Tinkercad. Tinkercad is our simulator. So that's where you can have your students doing a lot of work. So if you don't have the hardware immediately, you can actually use Tinkercad. They can actually write and do a lot with that. And then once they've got that set and you've got the hardware in your lab, you can then actually have them build the circuits and just copy their code from Tinkercad into the Arduino software, and everything works fine. Okay, so the way this course is set up, it's not like your regular CodeHS course. This is more an exploratory kind of course where students are actually, we give them the diagram, they get some information, and then they're coming up with a hypothesis as to what they're expecting it to actually do. Because a lot of this stuff is software controlled hardware, they don't really know exactly what's going to happen. So this gets them that concept of what we all want them to do. Test it, come up with an idea, develop it, and then, circle back again. So we get the hypothesized test, and we're dealing with electronic or schematics, which are diagrams, you're dealing with code and questions. And of course, this course is different, but there's typically a follow-up video for every lesson. Okay, the way this course is laid out, we have three main modules: the intro to Arduino, the program control with the Arduino, and then the advanced Arduino. Again, this is a one-semester course, and because of the hands-on piece, this takes a little bit more. So even though there's three modules, this is a full semester. Now, the modules are broken down into individual lessons. If you're familiar with CodeHS, it's kind of the same thing. We have the individual lessons inside the module, and as you can see here, typically most modules start off with a video. Now, in most of the other CodeHS stuff, immediately after the video is a video quiz. It's not that often here because, again, this is more exploratory. We are going to be more short answer, filling out a worksheet, and then working through that. Now, each lesson is broken down into activities, as we can see here. So if you've worked with CodeHS before, you're familiar with a lot of these activities, the video, the connections, the exercises, and some typically examples also. Okay, so if you need resources, all the Arduino resources are in this link here, codehs.com Arduino resources. I'm going to go ahead really quick and jump over to that page so you can kind of see what's laid out. So here, it's just breaking down what is that, the course flow, the examples. So this is a good starting point to get more information about the course after this video. Now, the big thing many of you will ask about is the materials list. We'll deal more with this a little bit later, but then here's the materials and the link for it's here, and you can kind of see that. And I'm going to give you some links a little bit later on where to get some of these materials, because again, I know that's going to be a big question, and we'll deal with it in just a little bit. Okay, so let's go back to our slide here. Now, the module breakdown, what each module does. The first module, again, students are learning to program and light up an LED. This is pretty much, just to give you an idea what we're talking about with an Arduino, you have ports. Let me go ahead almost. You have ports on there that you wire things up to. And these ports can either be what are called digital or analog. A digital port is either on or off, or it can receive a value that is either on or off. So with LEDs, you can either have an LED that's on or an LED that's off. So we're learning to do this kind of stuff. Light it up, change the brightness in various ways, and then we're going to introduce concepts of variables, write even more programs that can do a lot more. And we'll also utilize pseudocode as part of this because, again, have them come up with their idea, the flow, write it as pseudocode, and then they can take that pseudocode and translate it into that C++ Arduino language. Now, module 2, program control with Arduino. This is where we're going to take a little more control structures, looking at some of the advanced, or, instead of just everything being a sequence of steps, here we're actually looking at something where we're looking at branching based off certain things. If a sensor is turning on or it's activated, what happens? Turning on a motor for a certain amount of time, turning it off. We need these if-else statements and loops. So that's part of it. Now, before I go any further, let me just give you a brief overview of what the Arduino language looks like. It's pretty much broken down into two main functions. You have your setup function and you have your loop function. If you need to configure something at the start, you put that in your setup function. Everything else goes inside a loop. Because again, the Arduino is a microcontroller So it's going to run constantly. You want it to keep running. You don't want it just to run once, unlike a lot of programs you've written before. You want it to keep going. So in other words, I want my LED to constantly blink. So we have this loop, which is pretty much a function that gets called from an infinite loop. Okay, and the last module is the advanced Arduino. This is more a project-based exploratory module. Students will do some research on projects that are out there on the internet, and trust me, there are dozens of them. People, a lot of this is part of the maker community, making all kinds of things with Arduino and some of the other boards that are similar to Arduino, whether they are robots or sewables. You can put lights and sensors inside clothing and have it do stuff. One of the things I've written and created is I made my own holiday light display. So I've got an Arduino that controls multiple circuits, and I can turn them on and off at certain times and make little light patterns from that. But they'll do the research, and then they're going to come up with their very own project that they want to actually build. Okay, so who is this for? And again, they do need a little bit of basic programming experience. You could start off with Intro to Carol or Programming with Tracy, do some JavaScript. Now, with this actual course, because Arduino is C++, the language structure is very similar to JavaScript. If they've never programmed before, I would avoid going through Python, and instead I would actually do the JavaScript, because that way they're familiar with semicolons to the lines, curly braces for your blocks of code. The if statements work about the same. There's just a few things with declaring variables that's different. So that would probably be a better way of actually working it. But again, if students do have programming experience in maybe Python, they're coming in, it's just showing them the differences between the languages. Because an if statement, whether it's Python, Java, C, C++, JavaScript, they all pretty much work the same way. There's just a few eccentricities based off the language. So implementation options. So what you can do is you can create a course, and they just join that class, and then they go from there. Now, students have taken it. Again, you can have like a summer assignment where they do Carol or Tracy programming, and then they have the semester of your course. Or they could take both courses at the same time. You could have them going through a whole year course where the first semester may be something like introduction to JavaScript. And then second semester is where you're actually doing the physical computing portion. So any way you want to split it up, as long as they get some knowledge of programming, if they don't have any already. What I do is, this is my third year course. So they've taken 2 other years of programming with me. So I know all my students have that experience. And then we go in and we do physical computing. So if they're taking it currently, we do have the intro to programming with JavaScript with Arduino. So that could be as a full year course, or you can do introduction to programming with Python and Arduino, just to make sure if you're doing Python, the language structure is different. Okay, so what we're going to start today is looking at specific lessons, a sample lesson. So if you haven't already, please remember to go ahead and log into our workshop course. That's in CodeHS. You'll be a student, and we'll lead you through the actual lesson. Okay, so sample lesson introduction. We're going to look at the lesson and go through the module all together. We're going to look at lesson 1.1, welcome to Arduino. And then we'll look at module 3, the advanced Arduino, just kind of overview it, but go from there. So right now I'm going to go ahead and jump over to the actual course. So here is CodeHS, and I've got mine set up. So if you're familiar with CodeHS, if you're a teacher in there, you typically have to switch it over to the student view so you can actually view things as a student, which is what we're going to do. So let's go ahead and look at welcome to Arduino.
Chip, are you able to zoom in on your web browser a little bit, just so we can see the things a little bit larger?
Okay.
It's fine, just when you go back to the other screen.
Okay.
Yep, thanks.
As with this, we're going to start off with our introductory video. I'm going to go ahead and play it. I've got my browser set up, so you should be able to hear it. If you don't, please let me know.
Hi, and welcome to Physical Computing with Arduino. In this video, we're going to learn about physical computing and give an overview of the different topics we'll learn throughout this course. Let's jump in. Physical computing is creating or using devices that interact with the world around them. Think of a robot. The robot first senses their environment, thinks about the information gathered, and acts based on that information. A self-driving car is a great example of a device using these physical computing steps. Though this is a complicated system with many inputs and complex programs, the main parts of a self-driving car work the same as any system we'll build in this course. The car uses multiple sensors to detect its surroundings, analyzes what this data means, and then acts accordingly. In this course, we're going to be using Arduino devices to create programs that allow our device to interact with the world around it. Even though the Arduino looks simple on its own, it can be connected to control multiple components and sensors that can help it note changes in the environment and react based on the program you've written. Here's an example. We can use a temperature sensor to find the temperature of the room. It finds that the temperature is 19 degrees Celsius. It then thinks by applying this value to the program that has been written. It sees that if the temperature is less than 20, a light or LED should turn on, so it acts on this and lights the LED. In the last example, we used an if-else statement in our code. You've probably already learned a few programming concepts, such as variables, loops, and functions, and now we'll be able to put all of those concepts together to create physical machines. These concepts will form the foundation for how you can communicate with your device and program how it should sense, what it should think, and how it should act. We're going to cover a lot of content in this course and build some awesome projects. Let's take a deeper look at all the content packed into these 3 modules. In the first module, we'll go through the basics of our Arduino, such as how to light up and change the brightness of LEDs, and learn how we can use variables to make our programs more versatile. We'll build our first circuits to control LEDs and motors with our Arduino and explore how we can use pseudocode to structure our programs from the start and comments to make our programs readable to us and others. In the program control module, we'll learn how to apply control structures, such as if-else statements and loops, to create programs that will react to the outside world. We'll build programs that use sensors to detect temperature, light, and distance, and make decisions based on the information collected. In the final module, you'll have a chance to explore all of the capabilities of your Arduino on your own. You'll research, explore, and teach your peers about new sensors, follow directions to build an advanced device like those shown here, and have a chance to create your very own Arduino machine. Now it's your turn to look at some awesome projects that can be built with Arduino.
Okay, so that was lesson 1. Let me just get to where I was. I skipped around things. Okay, so again, we have our video. Next, we're going to look at the free response following the video. So going back, we hit continue. And I'm going to zoom in a little bit on my browser. Hopefully that's better. So from this point, head to one of the following sites, explore Arduino project that someone else has built. So you've got some there. You can actually use some other ones also, but again, the maker community has a lot of the stuff. That's why you see stuff like Hackster, Instructables, Arduinos, projects, and Make, which is actually part of Make magazine. So they look at it and they see what they want, they write about it, and then they actually share the link here. So they get to do a little exploratory, see what they can actually do with this. Okay, I'm going to go ahead and save and continue. And moving on to the next the Sees Me memory game. Sees Me, as Simon says, and I've got it right up here. Oops, I didn't put that. There we go. So Simon says, here's the actual device hooked up. Now, this is the way a lot of the Arduino projects are set up. They give you the components that are needed. They talk briefly about it. They give you the code, and then they give you the schematic. Schematic is the actual drawing. You're going to see a lot of stuff with Arduino. It's done with this software called FritzSync. Now I'm going to stop the share just for a second so I can show you what this does actually look like. I've got it wired up on my desk, and I'll actually run it through for you. So, okay, so if you see this, this is the actual board. with the actual wires. So again, it does require some knowledge on wiring. I'm going to go ahead and reset and give it a second, and it should start up. So then they push the button for red. It's like the old Simon game. And then it comes in and do the second one. So blue twice. And it works like that. Let's go back to the share. And it's still running. Let's see. I was on the screen. Okay, so going back to Sees Me. Again, they can do this. And the thing is, they can wire this up in Tinkercad. So you can actually do stuff like this with Tinkercad, which we'll get to in just a minute. So they explore this game. And let's see. They have to then write about it. You know, look at the code section, see how it is. Look at the schematic. It does require quite a bit of wires. So that's something that, like, so the whole thing here is they're answering these questions. And one of the questions here is, can you find matching pins on the Arduino board? So if you have them actually looking at the actual schematic and actually looking at a real Arduino, can they find the actual pins? Okay, so that's the first part. So we've broken up the game or the piece into that. Now, the second part is using Tinkercad. So this part, we're actually going to go through a video. We'll sign up on Tinkercad and then do the exploration. And I just need to make sure I'm in the right spots. Okay, so there. Okay, so we've done that. We've gone through this. So lesson. So typically when you're going through these things in CodeHS, you can implement them in various ways. The way I typically do it is I will show the video to all my students, and then they answer the questions independently, work independently. But on some of these exploratories or the examples, if students want to go ahead and work through it on their own, fine. Others will listen to me as we go through it. So your choices is they complete the work independently in class and then share afterwards. They complete it as homework, watch the video together. That's what I do. And then they, with this stuff, with the Arduino, I definitely have them working in pairs because you always want that second set of eyes, specifically from the hardware side, to make sure things are getting wired up there. Now, if you also want to, with CodeHS, every video that CodeHS produces has the slide deck. There's an option to go through the slides up at the top. And let me go back to that really quick and I can show you what I'm talking about. Okay, so if we go back to here, and if I go back to the actual video, up here you'll have the slides. So if you just want to go through the slides and you want to talk yourself, you've got the ability to go through it. You can do your own little say as you go through those slides. So that's one of the ways you can actually implement the lessons. Now, so all the ideas, you can create a list of projects that excite students. And that's a great one because, again, there are literally hundreds of projects out there. Have a scavenger hunt or a web quest where they find certain pieces out about this. Definitely setting up your Arduinos with programs before class. You can have them set up like I've got on my desk here. I've got the one with the says me, and I've also got the one that's at the beginning of the course, which has the ultrasonic sensor and the red, green, and yellow lights. So they can explore those, look at it, and just see hands-on. That's the way I typically do it. I'll have some circuits wired up at the beginning, let my students actually look at them. If they're interactive, play with them, and go from there. Now, again, you can, like I did, you can build the Sees Me and then just experience it. I will go ahead and inform you, there is a lot of projects out there. There is a lot of code out there. So this is the one thing that you have to really be careful of, is making sure, specifically with that last module, the module 3, that students are doing their own work, not just copying something off the internet. Okay, so let's move on to the second part, using Tinkercad. So let's go back here. I'm going to go to the video.
Hi, before we can start simulating programs for ourselves, we'll need to learn how to use Tinkercad, which is the online platform we'll use to build virtual circuits. Let's go. To get to Tinkercad, we navigate to tinkercad.com. If you've taken courses on CodeHS previously, you may notice this is a bit different. In this course, you'll be developing and testing programs in Tinkercad and the Arduino editor, and once you've successfully completed an exercise, you'll copy and paste your code into the CodeHS editor for your teacher to grade. Let's explore the Tinkercad platform now. When you first get to the main Tinkercad page, you'll need to log in. To do this, click the Sign In button at the top of the screen. Once at the login screen, click the green Students Join Your Class button. You'll be prompted to enter a class code. You'll need this code every time you sign into Tinkercad, so make sure you write it down somewhere. When you click Go to My Class, you'll need to enter your nickname. This should be provided by your teacher. Once you click That's Me, you'll be directed to your homepage. Throughout this class, we'll be creating circuits, so we'll click that button on the left-hand bar and click Create New Circuit. This is where you'll build all of your programs, so let's take a quick tour. This big gray space on the left is where you will drag components to build your circuits. We grab components from the library on the right-hand side of the screen. We're always going to need an Arduino in our exercises, so let's scroll down and grab one now. When a component is selected, a box with various options will pop up. The available options will be different for each component. When a component is selected, we can also click this button to spin our component. There's no way to spin back the other direction, so we can either keep spinning it until it reaches the starting position again, or just click this back button. If you'd like to leave yourself any notes, you can do that by clicking this notepad symbol and typing in here. All Tinkercad programs will default to pretty silly names, so to change the name to something descriptive, simply click the title here, and I'll name this one Blinking LED. Let's drag in an LED and a resistor. I want to connect the LED's long leg to pin 5, so I'll click the long leg and then click 5. A wire will automatically connect them for me. I can change the color of the wire here. I want to also connect the short leg to one side of my resistor. Note that it does not matter which side of the resistor is connected here. The last thing I need to do to complete my circuit is connect the other side of the resistor to one of the ground ports. Let's make that wire black. Now, my circuit is complete and it will work, but if I want to organize my image a bit, I can double-click on any point of a wire and it will allow the wire to bend. I always like to keep my components outside of the Arduino device so that everything is organized. You'll be building many circuits throughout this course, both virtually using Tinkercad and physically using your Arduino device. Before you are asked to use each component, I'll provide you with some information about what the component is called, what it looks like, what it does, and any other important notes. Let's take a look at the first components we'll be using in this lesson. Our first component is an LED, or light emitting diode. LEDs produce light of different colors. One important note about LEDs is that they have a long leg and a short leg. You may have to look carefully to tell which leg is shorter, but it is important to pay attention to which leg is which when connecting LEDs in your circuits. Many LEDs require a resistor to be used in conjunction with them, so let's take a look at what a resistor is. A resistor is used to reduce current flowing through a circuit or component. Resistors use different colored bands to depict their resistance value. We won't discuss how the color code works in this course, but you'll be able to change the resistance value in your simulated circuits in Tinkercad, and your teacher will provide you with the correct strength resistors for your physical circuits. Resistors can be connected in your circuit in either direction. Now it's your turn to explore the Tinkercad platform on your own.
Okay, so typically at this point, I'll go into a little bit of electronics instruction in my class. So we'll talk about what a basic circuit is, about how it has to complete. But then we also talk about some of the devices. So like for LEDs, it's a light emitting a diode, and that diode piece means electricity will only flow in one way. This is where we talk about components that are polarized. So in other words, there's a positive side and the negative side. That positive side is that long leg, as mentioned in the video. The negative side always needs to go back to ground. Now, the special thing with LEDs, you can wire an LED up directly to power, but it's going to allow as much current as possible to flow through it, and typically it will destroy the LED. So we'll talk about, that's why you have to have a resistor in there. The resistor, as we'll find out in a little bit, it is like putting your finger at the end of a hose. It's kind of restricting some of the flow. So you can also use that, and I use that in my class a lot, talking about flow of water versus flow of electricity, how you have some kind of the same kind of concepts in there. If I put something in front of my water, I'm resisting its flow. That's exactly what resistors do. Okay, so moving on to the next part of this module or this lesson. So you're going to go ahead and create your own Tinkercad account. So here, I would suggest actually joining in. If you're going to be teaching this, go ahead and join in as an actual educator. Now I've got Tinkercad up and running right here. So once you're up, I'm going to just go back to my page. Let's see. Tinkercad. So when you first get into Tinkercad, Tinkercad's produced by Autodesk. Autodesk is known for AutoCAD and some other things. So they've got a lot of pieces, but where we're focusing in is on the circuits piece. So you click on circuits, and that will go ahead and give you a basic circuit like you saw in the video, and pretty much you can then pull it up and you get to, I'm not going to do the blank canvas because I already got this wired up here. And on the right hand side, you can switch over to Arduino, and it'll give you a basic Arduino. If you want Blink, it'll give you the basic Blink circuit. So it's got some examples here that students can follow. Now, so going through this is how students, if you don't have the hardware immediately, you can do stuff here. And there's a couple of components here. You have the physical editor where you're editing your circuit, adding wires, adding components. And you also have the coding piece. So this is the program code that you would actually write. And then you can hit start. And as you can see here, I've got these two LEDs just blinking back and forth, but they're controlled via software. Okay, so moving back to our lesson. We've signed up for Tinkercad at this point, hopefully. And then follow the exploration. So this is what we're talking about with the basic lessons in the physical computing. This is how it's different than a lot of the other courses that are in CodeHS. Let me go ahead and scroll down a little bit. So the lesson is actually like a worksheet. And for many students, it may be a wise idea to want to print these out, or you can actually, since most of these are Google Docs, have it as a Google Doc assignment that students can easily get access to. But it's going to give them the instructions. It's going to walk them through some of the process. And then here's the exploration. So as they're going through this, they're wiring up the circuit in Tinkercad. They can then be answering this, whether it's electronically as a Google Doc, or they can actually do it through a paper copy. So with physical computing, again, it's not like the regular CodeHS course. So we're not using the editor inside CodeHS. And that's how the basic parts work in the physical computing lesson. Okay, so let's go back to our slide presentation. So that gives us this. And the last piece is that exploration follow-up video. I'm going to quickly run that. That's the next component here. So I'm going to go ahead and click continue. And we'll go through this video.
Hi, you just completed an exploration where you built your first circuits on Tinkercad. Let's summarize what you learned. We learned that we build circuits in the large area on the left side by dragging in components from the library on the right-hand side. We also learned how to use the buttons on the top left-hand toolbar to spin components and add notes. We learned that when an LED is connected directly to the ground and 5-volt ports of our Arduino, too much current is flowing through the LED, which can be dangerous. In the case of a tiny LED, the bulb will get pretty hot and can burn out from this excessive amount of current, but with different components or when using a more powerful power source, this could lead to a fire or explosion, so we need to be very careful when connecting components to our Arduino. We learned that to safely use LEDs, we should include a resistor in the circuit to limit the amount of current flowing through the component. We also saw how different resistance values can affect the brightness of an LED. This information will be important as you continue through the course and build virtual and physical circuits of your own.
Okay, so tell you what, let's go ahead and take a few minutes and you guys can go ahead and go through that exploration. So we'll say 5 minutes, go back to Tinkercad, have the exploration open from the class. So going back to that tab here, and follow through it just to see how the lesson actually works. And we'll be back in about 5 minutes and talk a little bit about it. I've been working with electronic circuits even before the Arduino came out. When I first was in college doing this stuff, and this is a good way of making sure students understand how to follow directions. So you give them a schematic, a drawing of electronic circuit, and having them wired up correctly, specifically with things like LEDs that are polar. In other words, you have to wire them up in a correct way. Now, if you reverse the LED the other way, it won't light up good at all because it won't allow it. But what I like about this first lesson is here there's no code involved. They're just wiring it up directly at power. So it either comes on when you start it, or as you saw in the first example, it just kind of pops. So it gives you a little background on how some of these components actually work. Okay, so we've done that. I did play the follow-up video, so I'm going to go ahead and so again, with the videos and the explorations, you can handle it in many ways, and that's the great thing about CodeHS. How you actually want to do the lessons is totally up to you. I have my students working completely independently. With physical computing, they're working in pairs, but in that way, I want them to make sure they're not destroying some of the electronics. And that's the great thing about Tinkercad. You can go ahead, test your circuit in Tinkercad, make sure it works before you wire it up. Because as you saw in the video and with Tinkercad, it's very easy to destroy an LED if you wire it up incorrectly. Now, don't worry about cost. LEDs are cheap. They're just a few cents for an LED. You can buy them. I buy them typically in 100 at a time for a specific color because I know they're going to get destroyed. So that's a problem. They can complete it as homework. Again, with Tinkercad, they can do this stuff on home. They can do it with a Chromebook, so it's very helpful. Again, I always show the video together in my class. Sometimes I have taken it where I just talk through the slides because I want to mention something a little more and actually go more in depth in certain parts. But again, how you handle this is totally up to you. Now, we can actually supplement these things, like learning about how color banding works. I've got a card I keep with me when I'm doing electronics because I don't remember what these things look like. So I've got this little card here. It gives me the color codes because I don't remember. Also, something else you could do if you're having a hard time with it, and I would strongly recommend doing this, invest in a multimeter. Most multimeters have the ability to actually measure resistance. So if you're actually too lazy to look up the colors, you can always just check it with a multimeter and figure out what it actually is. A couple things from that point of view. So let's go back to the share. So things you can do, like I said, color banding, how it works. I used to have this memorized. I don't do it as much anymore. And for me, it's a lot easier just to grab my multimeter and like, oh, okay, that's a 220, no problem. Definitely parts inventory. You're going to probably develop kits. So explain, having kids look at certain components and seeing what they are. Definitely in your kits, you'll have to lay things out. And it might even be you can find a picture of the color codes really easily online. Just take it, print it out in color, attached to every kit so the student has access to the color banding instructions. And also definitely more programming practice if they haven't programmed before. Okay, so with our lesson structure is that last piece, the free response pieces. So let's go ahead and go back to our lesson and look at the free response portion of the lesson. So right here, background and experience. So we're going to answer the following questions. What experience do you have with physical computing? Kind of like what you guys did when you first came into the workshop today. Have you ever programmed a physical device? If so, which ones? What programming languages do you know or are currently learning? In your own words, describe the following concepts. What are they and why are they used? Variable, function, if, else statement, and loop. Now, the nice thing with CodeHS is the splash screen for the exercises is always there. Students don't have to go back to it. It's always on the sidebar here. So they can always look at the sidebar. And then here, what CodeHS has done within the past few years is they've actually left the questions inside the response. So it's much easier to go ahead and type in your answers. So from this point, they're just explaining that, going through that. They can work, again, if you're doing it in pairs, typically for these kind of things, I have them do this stuff individually. So again, I want that individual response. I want to see what they truly understand, what they know. And once I've got that, we have the final lesson here, or activity of the lesson, which is goal setting. What do you hope to learn? What are you most excited about? And trust me, this is one of those courses where students are going to get really excited because, again, it's not just writing code, it's building something physically. What is an idea you can think up for a physical computing project? At this point, they've already explored some. They're going to get an opportunity to explore even more later on and complete the following sentence. If I can blank by the end of this course, I will feel successful. Now, I will say, this is the one course I teach that does, because the way some of the stuff I do, attract more females. And trying to get more girls in computing has always been a bit of a struggle. But when you start bringing out things like LEDs, and I've messed a lot with something called neopixels, they see these things light up and they understand they can control the patterns. I've had students who walk in my room or just walk by my room. It's like, can you build that for me for my bedroom? And it's like, well, take my class. You can make one yourself. So it definitely has that attractability for girls. So again, the last little piece I talk about, and we're pretty much done with the lesson at this point. So going back here, we're going to look at Module 3. Module 3 is the advanced Arduino. So the first two, again, we see intro to Arduino and then program control with Arduino. But we're going to look at that last one, which is the advanced Arduino. This is an open-ended module where they're going to do some exploration and then they're going to create their own project. So it's almost like a capstone for this one course. So the first lesson, again, similar to other lessons in the way it's broken out. You can learn about LCD screens, how they work, the new libraries, and that's the one thing you're going to learn when you're writing code here is unlike most of the other CodeHS courses, whether you're doing Python, JavaScript, Java, not so much with Java, you need to extend the language with these libraries. If you're using a ultrasonic sensor, you're going to have to load in the new library. If you're using that LCD screen, you're going to have to load in the library. Somebody's already written the code to work with the hardware. You're just using those new function calls. So you're going to learn how to make these new calls to functions and use some local variables that are part of it. Okay, so the second lesson is exploring a new sensor, and there are literally dozens and dozens of sensors out there. Let me stop the share real quick just to show you a few things. I've got these, I bought them years ago off Amazon. It says for Raspberry Pi, it's just a box full of sensors. I think it was like about 35 bucks. So you can get these fairly cheap. You can also do motors. You can buy robot kits. So you can have this stuff and students can actually use it and they can explore it. And this is the piece that makes this course fun. They get to build their own idea. So when we're talking about this stuff, we have all these different sensors. Now, sensors can be broken up into two main categories. Those that give you some kind of Boolean, true, false, on, off kind of results, or those which are considered digital sensors. And then there's those that actually give you some kind of numeric value. Like the ultrasonic sensor is going to return the distance, or a temperature sensor that's going to return the temperature. So based off how they do these, again, that's going to be some of the exploration, and there is a ton of material out there on how to use it. So they can explore it, look at what other people have done with it, look at how they've utilized the code, and then they're pretty much just, it's almost like Legos. Grab a little bit of this, grab a little bit of that, put it together and build your own item. Okay, so they can choose a sensor, and what we've got to set up is they do that, they do their exploration. It's almost like we've all done that jigsaw. You can do like a jigsaw activity. Everybody does their own little piece and they come back together and they teach it to everybody else. And again, if you want to understand something really good, go out and teach it to somebody else. And that's one of the great things here. Okay, the last piece, or the step-by-step Arduino project, students get to choose a project online. So they're going to go out and look for something. Again, there's a lot out there. They're going to actually, before they design their own, they're going to look at this and be able to actually, build something from this, get an idea as to how it's constructed. This will actually give them the idea, concepts they can use in the last piece. Now, for these, typically in 2s or 3s, you want to build. Again, a second set of eyes is always better. They can actually come up with better ideas. The way I explain when it comes to stuff like this, we need everybody's input, because what you may be thinking, what somebody else may be thinking, with that we can come up with an even better idea working together. Okay, and the last piece is the final project. So having gone through the exploration, understanding how some of these new sensors, now they're going to actually develop a new project. So here they have to go through the design process. So if you've taught an engineering class, you have the engineering design process. It's the same thing. You make your plan, you create it, you test it, and then you improve it. It's this cycle. Now, with the create, you actually have two components, because you're creating the hardware and the software. So the software portion goes through its own little software development cycle also. So you're working through a double development because you're working with hardware and software. Okay, so what we're going to do at this point is going to go ahead and do a breakout room. So if you want to learn more about the customizations, you'll be able to join that one.
Hey, Chip, we're actually going to hold off on this for just a little bit, because we want to dive in. We have a lot of questions about materials. If you could jump into the materials list, that resource document and all of the information there, because this is a very unique course. And I'll jump in if I need to just show that a lot of these materials that are not available on the free version, usually in most of our courses, are all available in this course, because it is so unique. So yeah, if we can start with the materials, that would be a good start.
Okay, so let's look at the course resources. We've gone through some of this. We've seen how this stuff works. Now, the materials list. This is the CodeHS materials list, which I've got up here. And you are going to need an Arduino with a USB cable. Now, the USB cable is a USB-A to USB-B cable, kind you typically use for hooking up printers. If you're buying some third-party devices like I've got here, well, they use micro USB on one end, which is helpful. Now, external battery connectors. Let me go ahead and stop the share real quick. I can kind of show you what we're talking about. Here, I've got a 9-volt battery, which is a barrel plug. This will plug into the Arduino, and I'm going to cover some, so you'll see like typically a barrel plug right here. Most of the Arduino compatibles have those. So if you want to run your stuff outside of having it wired to the computer, in other words, you want to demo it for somebody else or you want to see it live, you can actually work it that way. Okay, and let's go back real quick. Breadboards. Definitely you'll need to do a lesson about breadboards, but breadboards are easy way of actually wiring something up. They're pre-wired, so all you do is take what's called hookup wires, plug them into the holes, and then you can go directly from the pins on the Arduino into the breadboard, and it makes it a whole lot easier. So your wires are not all over. It gives you a neater connection. Alligator clip jumper wires, very useful for connecting other things. If you're using some other devices that are still programmable through the Arduino interface, like a microbit or even something like a Circuit Playground Express from Adafruit, you're going to definitely need the alligator clip ones. Now, alligator clip to male jumper wires. That's where if you're connecting something with the clips to there, typically I use a lot of those for like when I'm actually using my multimeter, I want to check something, verify it. They work from there. And again, usually how many? LEDs, again, they're very cheap. And I'll show you some websites as to where to get some of this stuff. Don't buy the big expensive ones just for these because you know they're gonna get lost, they're gonna get dropped. Buy inexpensive ones. And something you have to be aware of LEDs, they have what's called a forward voltage. You need to make sure that they will work with the power supply, and it will help you determine the resistor strength you'll need. Resistors, there's a few of them you'll want to buy. 220 ohm, 10 kilo ohm, those are the typical ones. But again, if you look at the projects, most of the projects tell you how many to do it. And a lot of it is to limit the amount of current flowing so you don't destroy the device. Male to male wires, you're gonna need a lot of these. They have little pins on both ends so you can plug them into the breadboard and plug them into the pins on the actual Arduino. With these, definitely colors are helpful. If you're using regular wire, what's called hookup wire, please make sure it's what's called single-stranded. It's got a single piece of copper in it. Multi-stranded wire doesn't plug into breadboards very easily or into the pin header. So single-stranded wire if you're going to do it yourself. And you'll need a wire strippers where you're making your own. I do both, but it's a lot easier to buy some of the pre-built stuff, and it's really cheap off Amazon or even some of the other vendors. Potentiometers, a little device that has a knob. As you turn the knob, the resistance changes. Again, very cheap component, easy to get. Micro servo motors. These are little servos. Tell you what, I'm going to get this way. I'm going to keep that up and just show you what I've got. So this is a micro servo. It's a little motor and it will swing 180 degrees. A lot of these things are used for remote control devices, remote control cars, airplanes, and things like that. And I'll show you. This is the potentiometer. Little knob on top, you turn it. Buttons. You're going to need buttons. They're very cheap. I've got a whole drawer up there, but they're just these little buttons like there, and they're just on-off kind of items. Ultrasonic rangefinder, that's this thing, looks like a set of eyes. It sends out an ultrasonic signal, and then the other one receives it back. Photoresistors, let's see. Photoresistors, also known as light detectors. As light hits it, the resistance increases. So goes from there. Temperature sensor. And a lot of these are temperature and humidity, so you can check from that point. DC hobby motors. I've got them in a box. Motors, you have to be a little careful of. They tend to draw a lot of current. So typically when you're dealing with DC motors, and sometimes even with some of the bigger servo motors, you're going to need what you're going to need is a motor driver or motor controller. Typically, it's a board that looks like this. You can hook up multiple motors. It has its own power supply. So what it does, it takes the signal from the Arduino and then pulls the amount of power from its own power supply so it can run it at more current. 16:2 LCD screen. Again, it gives you the price there. You can get them They're making these now where you don't need to wire in as many. They've got some that are called I2C LCD screens where you don't have to hook up these 7 or 8 wires for it. You can just hook up 3 or 4. They are pre-wired. They are a good way of getting information back from your project. If you need some kind of numeric value, you can easily print them out. Specifically, if your project is going to be not connected to the computer. So now, let me show you a few sites you can do. There's a lot of kits out there. One of my favorite sites is actually Adafruit. So if you go to adafruit.com and go under products, they have Arduino. And they've got kits, boards, devices that you can actually do.
Chip, could you share share your screen so we can see that site?
Oh, it's not. Oh, I'm sorry. I forgot to redo the share again. Give me a second.
No problem. This is all really good information. And some people were asking about supply chain issues. I know we were talking about that before we started. So if you have any input on that as well, that would be helpful.
Okay, so this is Adafruit. Adafruit, again, probably our school system. It's one of our vendors. It's where I order most of my stuff. They do have their own version of an Arduino called a Metro board. I like this because it uses the micro USB instead of a USB-B cable. So I've got a ton of micro USB cables, so it's a lot easier, but it still is programmable exactly the same way. Even though it doesn't say Arduino on it, this is an Arduino. Now, again, they have all these items that you can do. This is that battery connector. Here's what are called shields. You can do these boards that plug in, and you can plug in the board. So if you need an LCD and you don't want to do all the wiring, this is a shield you can just plug right on top. The motor controllers, again, you can use those, wire up lots of different types of motors. You can play sound. This is the typical cable you're going to need for a US Arduino. Again, GPS, all these things. Now, the nice thing with this website is they tell you if it's in stock or not. For most of the Arduino stuff, the basic stuff, it is there. And they offer kits also, so you can actually look for educational kits. One of the things I do like about this is they have their own site to learn more. So if I type in Arduino up here in the Learn, let's see, Arduino compatible. So they've got a bunch of little things. You can see kits, what you can buy, different projects you can work on, how things actually work. So a great site. Another great site is SparkFun. SparkFun, similar to Adafruit. I've used them for a vendor in the past. I don't use them as much because, again, my kind of go-to is there. But if I just type in Arduino, or actually, I think they have another product menu. Yeah, Arduino right there. And they've got kits you can buy, inventor's kit, the robot kit. They sell their own compatible, which is called a red board. So it's just like the Arduino. It's kind of like the Adafruit version. It uses a micro USB, but it's an Arduino for all intents and purposes. So you can buy the Arduino and the kits together and purchase them that way. Another place for project exploration is MakeZine. MakeZine is where a lot of makers go, and again, they've got concepts and stuff, so you can easily come here, books and kits. They do sell stuff through it, but it tends to be much higher cost. So I'd be a little wary of buying stuff on MakeZine, but if you want to look research projects, it's a great place to go. So from that point, do you guys have any questions for me just about this before we get into the breakout rooms? Or is there anything else I need to cover? Because I've gone through the actual list. And again, the sensors, you can get some sensor boxes. Let me see if they do have them still on Amazon.
So we did have a question that I'm not sure if you are able to answer, Chip, about living in Canada and having a lot of those import fees kind of hitting hard there. Do you know of any companies that would be more helpful in that scenario?
For many of these things, they're not protected hardware, so you're really not going to have to pay a whole lot. Like I said, here's a sensor kit for 30 cent sensors. For import export, Arduino is actually produced in Italy, and the Arduino site. Let me just go to Arduino.cc. If you're looking to buy an Arduino, they will give you links based off where you are. So here, and then places to actually do it, boards, kits. So they're going to do it, but I don't think there's an import fee into Canada. I could be wrong. But again, Arduino starter kits, not a bad thing to do, but think about it, you're going to need one for every 1 or 2 students. So again, you can see the price is going to go up. But I would start here with the Arduino site and seeing from, if you're outside the US, what some vendors are. If you're in the UK, I would probably start with the microbit site. It has a shopping thing, because if you're using microbits already and you're using some sensors with your microbits that are not built in, you can still reuse those with Arduinos. Even if you're doing Raspberry Pi, the sensors and the wirings are totally compatible. So don't worry about just buying the stuff and it only works with Arduino. These sensors, the wires, the power supplies tend to work with many other devices. I hope that answers it.
Yeah, that's great. And Chip, if you could show your organization that you were showing us earlier, and how you use that with the students in the classroom, I think that is really important, because it does add up, and you don't want to have these all these materials go into waste.
I buy these boxes from Home Depot, little storage boxes, and inside, I can't tilt it, but I mean, I've got breadboard in one spot, the Arduino in one spot, a bunch of wires, sensors, all broken out. This is the teacher box. Typically, I'll have a sheet taped onto the top here. That's the inventory sheet that explains exactly what's in here. But I mean, I've got like 10 yellow LEDs, 10 green ones, 10 red ones. I've got a bunch of different resistors. We do RGB LEDs. Again, these are the little buttons. They're tiny little things. I've got like about 10 of them, and then some other sensors I just drop in here. But again, with these, it's a good way of keeping everything separate. I number each kit. Students are assigned a specific number. Weekly, they'll do an inventory. They'll turn the inventory to me. And then during my planning, I may grab 1 or 2 and just do a quick inventory check to make sure everything is there. Okay, so let's go.
Awesome. Thank you. And if we can have, did you have more to show, Chip?
I'm trying to see if I've got everything covered with the websites.
Yeah, if you could just go back to that whenever you're ready, to the full resources page, and just show where all of those, because I know a lot of people who either haven't used CodeHS before or have only used the free version may never have seen a lesson plan or those handouts, because they are included on the pro version for all of our other courses.
Okay.
But this is something that is really, really helpful for this course.
Okay, so one thing I've done with this course, so since you've signed up with this course, let me go ahead and go back to it. The websites I've shown are under resource workshop resources. I've added a lesson here, material resources. So I've given you the link for Adafruit's Arduino page, the Learn page, SparkFun's Arduino, their Learn page, DigiKey. Let me go ahead and show you that website. It's not a vendor for my school system, but if I'm personally ordering stuff, I can get it cheaper from there. You really need to have a fairly good understanding of electronics. They are a major electronics components vendor. So again, you can see they've got stuff for Arduino, but they also sell electronics or electricity based components for a lot of different other things. But I've got all those is in the materials portion of the actual course. Now, with most courses, let me go ahead and go back to the actual course. I need to get out of the student view. Let me do it this way. Okay, and go back a little bit more. Okay, so I'm trying to get out of
If you just change from the student on the little blue bar on the left, student to teacher.
Oh, there it is. Okay, yeah.
Yeah.
I keep looking at the thing at the top. Okay.
I know, so many ways to get to different places.
Okay, so getting back here into the course, if I'm actually looking at the assignments, now, this is the great thing that CodeHS gives us, is the ability to actually look at this. So let's look at, there's a link here on the teacher view for Welcome to Arduino. I'm going to go ahead and open that up in a new tab. And here's the lesson plan. So it walks through what the, if you're writing if you need to turn lesson plans, here's your objectives. You could use them for your actual goals or whatever, going from there. Here's the breakdown of the actual thing. If you want to use the slides without the video, you got that. If you have students where you are dealing with some kind of differentiation, you need to print the slides, you can. Now, again, those are pro features. But again, from the lessons, if there is a coding thing, they'll give you the solution here. The problem guides, these are where you actually see the actual worksheets. So you click on that, and it's going to bring up the worksheet from here, and there it is. So you can actually get there and work from that. Size me game, background experience, that's the one we're looking at also. So goes through more details as to what it is, what to expect. But the main thing is your handouts. So you have the teacher version and the student version. So for the exploration, this is the document that they'll have. You can easily print it from here. And again, you don't have to be on the pro version to get access to this stuff. If you notice, there's no pro icon here. So you're getting the student version and then the teacher key. And there's extra stuff in here. If you wanted to do that scavenger hunt, there it is. If you're looking to do the inventory of an Arduino kit, there it is. And that Arduino reference sheet right here. And it gives you more information about how Arduino works, commands for the language. Again, it's very similar to JavaScript if you've done JavaScript. There's just a few commands you need to be aware of, but knowing that setup and that loop piece is what you need to do. Okay, so that's what a basic lesson is. And then the planning notes. This is where I go to a lot, because the nice thing they also give you is, more details to what we're talking about. So if you need some more resources for your Arduino, the Arduino explorations, tells you the handouts, has a link to it, lesson information as to how to actually work it, that you're learning the strategies. This is the nice thing if you need to plan out how long a lesson is going to take. CodeHS has done a great job giving the times, approximate times for how everything is going to run. So when I'm doing my lessons for the week, and I need to figure out, okay, how many lessons am I going to be able to cover? I'll go to this spot in the actual lesson plan and time out the whole lesson. Okay, well, this lesson overall is going to take 70 minutes. Okay, I'm going to break up into 2 classes. So we'll cover down to maybe this point here in the first class, and then we'll cover the rest of it in the second class. Gives you great information on prior knowledge, and if you need access to the slides, here's the slides going through for each one of those videos. Something I use also is the discussion questions. I use them like the beginning of class one. If they've got the scavenger hunt sheet here, but for a lot of them, what it is they'll have questions, and I'll use those questions as my warm-up. And end of class, here's your ticket out of the door questions right there, and then the possible responses for it. They give you the information for modification. You got students that are really going through it. If you're doing any kind of ESL, well, not ESL, but special ed, but it's not special ed anymore. It's, different word, but yeah, we've got the differentiation here to handle with all that. If you need to tie it to standards, here are the standards that are associated with it. So again, they've done a great job on creating this curriculum and tying it all together. Okay, so at this point,
Awesome. Thank you so much, Chip.
okay.
Yeah, I think diving into that, and again, all of that can be found on that codehs.com/Arduino resources. That is, I would say, your starting point. That has links to the materials list, to all the lesson plans, to all the handouts, to everything that we think you would need when you're getting started with this course. So that is a really good place to start. All right, thank you. So now we're gonna do our breakout rooms. We are gonna have Joni stick around in the main room. So if you stay here, you're gonna get some information on how to get started with CodeHS, how to get one of these sections actually set up for yourself, how to customize those. If you want to take an exercise out or you want to add something else in, you can do that very easily on CodeHS. And me and Chip are going to head into breakout room 1, where you can ask him more specific questions. I know that you guys have a lot of questions about these, the materials and how this course actually runs in a classroom. And Chip is the expert on how to answer those. So if you would like to join that breakout room and get more information about the course or the materials or ask Chip anything, you're going to click on that join button. So you'll see on the picture at the top of this screen, you are going to click into join. And Kanisha, I wish I could be in both. I totally get you. We can keep recording the main room. So if you want to hop into the breakout room and ask a quick question and then pop back in, that's fine. But you can always get what is recorded during that main room session. Joni, Lindsay, that will work, right? For us to record the main room during that time?
Yeah, I think that we can just keep this going so that if you want both, go to curriculum, because we can't record that one, but we can keep the recording here on this one. Pretty sure.
Perfect. Okay, that sounds great. So if you have any questions, you're going to choose to join in that room, and you can always pop back into the main room whenever your question's done. So the breakout rooms are opened. You're just going to have to open that breakout rooms tab on your Zoom bar and click the join button to head in there. So me and Chip are going to head in there. Chip, you can stop sharing so that Joni will take over here, and we'll meet you in the curriculum chat breakout room.
Hey, everyone. Hey, Chip, do you need us to assign you to the, Lindsay, you might want to just throw him in the other one for him real quick.
Yeah, if you want to do that.
Yeah, I just assigned you. I think you do have to click on breakout room and click join.
Oh, he got there, right? I think I saw him go away.
Yes,
All right. So, hey, welcome everyone. So in this particular breakout session, what we're going to do is I'm going to kind of start at the beginning. So this is kind of first. It's going to be a combination. So the first part of this, I'm going to show you, okay, what do I even do to get this course? So it's for those of you who are new and you haven't been on CodeHS maybe, or you're not sure, you've heard of it, you played with it, but you don't remember how to make your sections. So I'm going to show you how to create your course and get a section up and going that you can have students enroll in this year and or at any given time. And then as soon as we get that done, I'm going to then jump to customization, which basically will be where you can add your own stuff. So if you have even taught this before, or you've had something that you always use in your classes, how do we get that stuff added? And we have a lot of different resources that you can pull in, and you can even create your own. So I'm going to show you how to do those. So that's what we are going to try to accomplish here in this little breakout session. Okay, I'm got to get you guys where I can see everything that I need to see first. And I'm sharing my screen with you. If anything comes up, please make sure that you just interrupt me and stop me, because I'm just going to kind of roll with this. Okay, so when you are signed up as a teacher, now I do want to tell you, you do have to be verified as a teacher before you can do any of this. So when you sign up as a teacher, if you have not had a teacher account before, there's things that you're not going to be able to do until you actually get verified as a teacher, which is a good thing. That's how we protect all the materials so that you guys can use those as teachers, and the students can't just pretend to be a teacher and get all of this stuff. So once you're verified as a teacher, the way that what you're going to do is you're actually going to create, I'm going to start with creating my section. I need you to understand that creating a course and creating a section are two different things. So the course is like, hey, what subject do you teach, or what classes do you teach? And what you would say is, I teach Intro to CS. I teach web design. I teach, and you just name the courses that you teach. Where the sections, think of that as your periods. That's how, I'm from Indiana, that's how we kind of say it. So we've got 7 periods in the day. So I may teach a course, Arduino or physical computing, 2 times a day. So I would have one course, but I would actually create 2 sections. So I'm going to show you how to actually go through that process. So first of all, when you are in CodeHS and you sign in, you have to make sure that you're in your teacher account versus your student. Now, you guys are in the workshop section as a student. When you go to your teacher account, you probably see nothing right now. And so you're going to go to your teacher account, make sure you're on teacher account, and at the upper right-hand side is a button that is where you create your section. Remember, think periods. I'm actually going to create it as a period. So I'm going to go create new section, and it says, oh, okay, well, what is the name of this section? So I'm going to say, okay, I teach period 2, and it's physical computing, which is the course that we are talking about today. So I just created, this is for period 2. When I go to create period 5, which is my other physical computing, I'll make a brand new section. So this is only for my period 2 students. Go ahead and click on next once you get it created. And this is where we choose our course that we are assigning to the section. Like, okay, section or period 2 physical computing, which course is it that we're teaching? I'm going to do a find and look for Arduino, because I can choose from a lot of different courses. If I go back here, I can see that there's tons of courses that I can select from. So just using your find so that you can find what you're looking for is going to be the best option. I'm going to choose my intro to physical computing with Arduino, and I'm going to just click on the word choose. And that's going to add all the stuff from this course and dump it into my period 2 section. So I'm going to go ahead and click on choose, and it starts to create my section for me. Now you're going to notice that now up in the upper left-hand side, this is working with my period 2 physical computing. This is my roster of all my students that are in this course, which is absolutely nobody right now because we haven't had anybody add themselves to my course. And it shows you as the teacher. Also on the left-hand side, you'll see that if you go to your sections, that you now have a new section, period 2 physical computing. So you've created your section, you've told it what course you're going to teach, and then you also have, you guys know when we gave you the link to get into our workshop section, you actually can get that for your students. So now I could have anybody join my class here by going to codehs.com/go/878AC. So you would just share that with your students, and they would enroll themselves into this course just like you enrolled yourself into this section. The other thing that you're going to notice when you're in as a teacher now is that when I go to assignments on the left-hand side, so I'm going to the assignments for this class, and this has the 3 modules that you guys actually see in your workshop section because we made your section from this exact same course. So we have intro, program control, and advanced are all of the lessons modules. And then for each module, you have your lessons, and for each lesson, you have all the activities. And as a teacher, the little red button on the right-hand side of each one of these lessons, those are your lesson plans. So those are the things that Chip showed at the very end. Okay, so that's how we actually create our course. So you create your section, you name it, you tell it which Arduino course that you want to get the assignments from. And then to go back to your roster up here at the top, we have roster and assignments. I can go back and forth between those two up here at the top. Okay, now if you guys have any questions, since we're a little bit smaller group, just go ahead and throw those into chat. And Lindsay, you can interrupt me if anyone has any questions that we need to answer, or you can answer those in chat too. Okay, so how do we actually go through and customize our course? So you may have additional materials that you want to add that your own. We also have some from CodeHS. So the first thing that I'm going to show you is that down at the bottom of your assignments, I'm in my assignments. If I go clear to the bottom, it has this little search for content. This is the way that we can get CodeHS content added to our course. I'm going to give you an example. So let's go up to search for content. If there's any supplemental material, so you're going to notice if you use CodeHS for any other courses or other courses also, you may see some supplemental material that you can use. If you're used to that, if you're a CodeHS user and you're like, well, hey, aren't there supplementals for this? For this particular course, there are no supplementals. So it just depends on the course itself. But you can also get things from any of our courses and add it to this one. Give you an example. It's the first semester. It's around Christmas time. We've got like 3 days before Christmas. The kids are so ready to be gone. And you decide that you want to do something slightly different for about 3 days or maybe just a day. We can go to the course catalog and add a module in here that is something that's just something that they could play with that's fun. Let's go see what some of those would be. So I'm going to come to course catalog. I'm going to click on that. So I'm going to the course catalog to find something to add to my course. And I'm going to come over here to Hour of Code because I just need a day or two to have the kids do something that's different. And when I go to Hour of Code, I can flip through here and go, you know what? I'm going to have them play around with creating virtual worlds. That sounds like something that they might enjoy doing. So I can come to that. I can actually look and see what units are in there. So it's just a small unit because it's Hour of Code. And I can click on Assign. And I have to choose which course I want to add this to. So I'm going to get the drop down. And when I go through, I'm looking at my course to be, the course that I'm adding it to is called, what did I name? What did that course name? Physical computing, right here. Introduction to Physical Computing. You'll notice that it actually made that course. I didn't go in there and make it. It made it automatically when you created your section. So it created a course and it gave that course a name with your login name basically, or your last name that you have on there. So I'm going to go ahead and say, add this to my course, and I assign it. And now when I go back to the course, I'm just going to get out of here, go back to my section. And we should see in my assignments that I have a new module called Hour of Code. So I can put it right into the course that I have my students in. I don't have to have them go somewhere else to be able to get to it, because you guys know that if you've got tons of kids, they're everywhere, right? So I can just click on I can just add it to my course, and I can say, hey, you guys, let's move down to the Hour of Code and let's do that today. All right. It always adds it to the end of the list. Let me show you how you can rearrange your modules. So let's say that I actually want this to be one of the first days that they just play around with this. I don't know why you would do that, but we're just going to say to you click on the little edit button, and it allows you to drag and drop these units anywhere that you want to put them. So if I want this first, I can just bring it up to the top, say I'm done, and now Hour of Code is at the top. And you can change that at any time. So if you're getting ready for the hour of code and you want them to not have to figure out where it is, you can just move it. And the kids, when they get in, they're going to see it at the top now. Now, if you decide that, you know what, this is not what I want to do, we also can remove any content also. Anything that you have, whether it's a lesson, a module, or even an individual activity, the 3 dots on the right-hand side are going to allow you to remove anything that you want to remove. So as we go through here, let's say that we decided we don't want to give them this connection right here. So I could go to the 3 dots on the right-hand side. I can choose to have it remove. It's going to prompt me. It's going to say, are you sure you want to remove this assignment? I'm going to say, yes, I do. And now it's no longer there, so the kids can't see it. I can do that with an entire module if I want. If I added something and I decided that was a bad idea, I can just remove that module and I'm back to the normal. Okay, so that was how we added content from the course catalog. Right, now the other thing that you might want to do is you might want to add your own stuff. So I'm going to kind of go through all the different types of things that you might want to add. Let's start out the button on the right-hand side. Click on Add. Notice that you can click on Module, Lesson, or Assignment. So if I want a module in your workshop section, you'll notice that module in the very top that was one that Chip actually made. So you might have stuff that you do the very beginning of the school year. You could create a welcome module for your students. So I'm going to go ahead and show you how to do that and what it looks like. I'm going to click on Module. It's going to say, hey, what module do you want this to be? What is the title? What do you want to call it? And I'm going to say, welcome to my, let's see, Mrs. Neer's physical computing. And I could put a little icon in there. So that's what's going to go along the left-hand side of each of the modules. You could choose your own image to add. I'm going to create it, and it's going to be at the end of my list. Remember that we can go to the edit. We can bring those to the top. And now I have a module with nothing in it yet, okay? So if I want to add stuff to this module now, I'm going to click on Add New Lesson, and this is going to be Introductions. And I'm going to create that lesson. Now remember, lessons, you guys, lessons are these right here that have activities as part of them. I just made a lesson, but I haven't done any activities. The activities are what can be anything that you want to add in here. So let's go see at what some of the activities could be. So now that I've got my module, I have my lesson, and I'm going to add a new assignment. And here's all the different types of assignments that you can create. Give you a second to kind of read through these. We can create coding exercises. We can create quizzes, practice problems. We can embed a video or an article. We can give them some notes. We can ask some free response questions, and we can embed another activity. So if you use something like Padlet, or any kind of quiz type of activity, if it's allowed by the other site, you'll be able to embed that into our site, and you don't have to go to an outside site. You can have them get to it right there. Okay, so let's just start out with free response. Since this is introductions, I'm going to ask for a free response. And since we're not really worried about their programming language on this one right now, it's just the beginning, I'm just going to ask them to type in plain text. So I choose plain text. I title the assignment, introduce yourself, and then I would give some kind of information that I want them to read about what they're supposed to tell me. I can save this. Try that again here, and I can preview it. And now it looks just like all the things that we've made, where when you go to it, it gives you sort of an introduction. This is what we're supposed to do. Let's go. And now the students can just type their answers over here because it's plain text. They can introduce themselves and they can submit their assignment. And it will take them.
Before you move on from this, creating your own assignment, we had a question about how to make sure that they're not on the problem bank for everybody to see. And I know some of them have an advanced setting button at the bottom that lets you see if it's in the, here we go.
Okay, so go to advanced settings, all settings. Whether it's in the grade book or not, the grading settings, due dates, availability, allowing blocks, extra description. I'm not seeing that, Lindsay. Is that something that you can walk me through, or is it something that we can get back with them on?
Well, I can show you where it is for, like if I make a new assignment in like a Java assignment, at the bottom, when I make the assignment, it shows me I can get to my advanced settings, but it didn't show up for you. So I'm not sure. It looks like you have that advanced settings gear wheel. I'm wondering if it's a pro feature to be able to take it out of the problem bank.
Yes, that might be a true statement. We can check on that. So only pro. So any custom add-ons are public if you use them free. I do think that that's something that, Lindsay, if you want to check the knowledge base on that too, we might have a, in the background there, we might have an answer for you for that, Wendy.
Yeah, thank you, because I think our school we have to be careful. So I didn't realize that. Yeah.
Okay. Yeah, because when I made this, I did not go and create this. I just made this section. I didn't go and make it a pro section right now. And so I might not be able to get to what we normally would get to with the pro settings. So
yeah, we don't have pro, so I'm not sure then.
Okay.
That makes this really tricky then for us. I'm so excited with adding custom assignments, but if it has student name or something.
Okay, great. Yeah, Wendy, we will, Lindsay's going to work on that in the background here while we move along a little bit here. That's a great question. A question that I obviously didn't really think through what we do have access to on that. So nice job. Okay, so that's our free response. Let's go. I want to show you something else. Let's say that we want to, we found this really cool video that we want to embed in. So I've got this YouTube video here, and it's how Arduino is open sourcing imagination. And so if I would like to have this embedded into my course, I can do that. The way I'm going to do it is by choosing video. So I did the exact same thing. I just added, I'm going to put these all in introduction, so it's not going to make sense. Let's finish creating this. So I just created another new assignment. I'm going to choose a video this time. I can crowdsource, and I can share this video, get the share link. So I'm going to come back to YouTube and just get it normal way. There's nothing special about it. And I just put that link right in here. I can change any of my settings. And so again, if we can figure out if those go into playlist public or not, and we can preview this one. And it's actually right inside the course. So when I go to my course itself and the students see that module, they will see the crowdsourcing video that I want them to see. That keeps them from going to 50,000 other things also. Let's add another assignment. What if I want to add in, you guys saw the, let's see if I can find it. Yeah, I'm going to copy this link. You guys saw the handouts that Chip showed you as resources in your lesson plans. You can also Let me start here instead. You can also get to those. If I'm down here and I want to go to my lesson plan, and you get the handouts, and you open a handout. So exploration, let's go with the scavenger hunt. So I get this, right? But what if you want to be able to get to it right from your assignments from the students so that you don't have to like pass this out to them or share it any differently? You can use this if you create your own, make a copy of it or download it, then you can share that with your students through the actual page itself. So let's say that on intro, the very first thing that we wanted to do on the Welcome to Arduino is to do the scavenger hunt. So in even our modules, you can add a new assignment. So I'm going to add this worksheet by adding assignment. And for that one, I'm going to embed this article. And I am going to put in here scavenger hunt. I'm going to paste the link that because I've downloaded it and it's on my drive now to be able to do this. And I'm going to go to save that and preview it. And if all works well, yes, the students can now get to this and be able to see it right from your course itself. So now I've added in the scavenger hunt, and it's supposed to be the first thing. I do want to point out when you use this edit button, it only allows you to move the modules. If you want to move an activity within a lesson, we have to use the 3 buttons and use the move up. So I just have to move this up or move it down to wherever I want it to move to. It does not have the drag and drop with the edit. So let's say that's the very first thing I want them to do. And now the students, when they go into their course, the first thing they will see is this workbook or worksheet that you wanted them to do first. Okay. Do we know how much time we have? I'm just going to keep going until they all show back up, I guess.
We have about 9 minutes left.
Oh, great. Okay. All right, great. Oh yeah, Pam. Yeah, it's just so nice because you just have everything just like literally right here for the students. Let's go see what else that we have that you might be interested in. Oh, giving students notes. So one of the things, like when you want to give students links and you're not virtual, when it's virtual, you can throw it into chat, right? But if you're giving links to students, sometimes it's nice for them to be able to just have those all in one place when you're not virtual. And so if you use the notes, you can actually, I say that, but now I'm wondering if that's a bad example. Let's say resources. And this is going to be a list of all my resources that I want. That is so not what I wanted to do. Coming back, let's go back here to activity details. Here's where I would put the notes. And yeah, I can link. So if I had one of those resources, and I don't even know what one of those was. I'm going back in chat to find one, DigiKey, right? So I could put DigiKey and I could make that a link to whatever it's supposed to be. I don't know if I actually did that. When I say that, when the kids open this up, what they're actually going to see are the notes that you want to give them. So that could be any kind. It doesn't have to be resources or whatever. You can literally, you've got notes from the day. If you've got whatever you want to share with them, you can share with them through the notes also. Now I see that the whole crew is back. Are there any of these new that you were, the coding exercises and the practices are code based? So as far as the Arduino, those two are not going to be ones particularly that you would use in this. definitely the free response. You could ask them to share a link through their free response. That would work also, so that you could get anything that you would need from them if they're uploading things or whatever. The notes, the article, and the video, those 4 are going to be awesome for you guys to use for this class. So
we have one question, Joni, about PDF worksheets. Can we use Kami within CodeHS, or would that need to be outside of the platform?
I've never used Kami.
I don't
know that answer.
I don't believe that it's compatible. I believe you would have to do that outside of the actual website.
Okay. Anybody else know that answer, that you've used it, or because if anyone has that answer. If not, I'm now, you've made me curious now, so I will go be checking that out. Okay. All right. If there's anything, you can always go into the question parking lot and put it in there, you guys, and I'll still answer that in there even as we kind of close up shop here, and I might be able to answer or give you some resources, because our knowledge base is amazing. So when you check out some of the resources that we have, you'll notice that our knowledge base will give you a lot of answers to some of these questions too. So make sure you check that out.
And Joni, did you show them the knowledge base in the support toolbox?
I have not. I think that now would be a great time for somebody to, if you want me to share mine again.
I got it. I will share the slides and then that as well. So
okay, that's what I thought would be. Okay. Thanks, Julie.
So yeah, this is a perfect segue, because I think we were even talking about this at the end of our session just before as well. The support on CodeHS is here for you, and is like, our job is to make your jobs easier. I know that there are a lot of sites where you ask for something, or you're like, I wish this existed, and you just sit there because it will never exist. I mean, we come out with new tools every single day. There are new tools coming out because teachers are saying, this would be easier if I could do it this way. So anytime that you're like, I wonder if this is possible, honestly, there's a lot of stuff that people just don't even know are there, that it might already exist. So I highly suggest checking out this toolbox and going to the support section and using either the contact us if you just want to send us a message, or this knowledge base is a really awesome way to just search for whatever you're looking for. So you search Arduino, you're going to get webinars that we've done in the past when we introduced this course. Here's a whole list of all the information, FAQs, how to integrate physical computing into your course, anything you need to set up technically. So there's a lot of information here. This knowledge base is an awesome place to go for some extra help. All right, so let's finish up here. So we have lots of other ways for you to stay engaged and connected with CodeHS and with the community. It's so nice to have other teachers in similar places, doing similar things in their classrooms. And I know a lot of these teams in schools are very small, right? When I was teaching engineering, I was the only teacher teaching this course. So I didn't know who to ask when I was curious about something. So being a part of the CodeHS community is really helpful. We have a certified educator program, which is what Chip is a part of. He's a teacher trainer. And then we have a bunch of these workshops, either led by other teachers or by the CodeHS staff, depending on what the information is. So many of those are throughout the year, and they're free. We have a Slack channel. If you are someone who uses Slack to communicate, you can network with the community there. We have a micro-credential program that we can give you more information on. If any of these, there's some links in the chat, but you can always ask in support if you need more help with that as well. And we have lots of social media, a very active Facebook group, and a Twitter and an Instagram where you can get some updates as well. We have 2 workshops coming up in the next week. So on Tuesday, we're going to look at Python in the sandbox. So if the sandbox is something you've never seen, or you maybe have used a little bit and you're like, I don't know how to put this in my classroom, that is a really nice way to let students create their own programs. So we're going to be talking about that on Tuesday. And then we have a getting started with CodeHS. So there were a lot of people who were brand new. I'm sure you learned so much from Joni in that session. But if you're like, I need to go from like total scratch, like start at ground zero, this is where to go. So this is going to be a really good way for you to get an overview of those tools and all the things that you can do with CodeHS. So you can sign up for any of those using that link. And last but not least, we really, really value your feedback. So if you could please fill out this short workshop survey, it's really helpful for us to know, did you get what you came for? Was this workshop what you expected? And if not, how could we make it better? Because we do these every year, and this is probably my like 4th time doing Arduino because it's only been around a short time, but every year that we do it, we improve based on what you say. So please fill out that survey. That's really helpful for us. And if you have any other questions, any last thoughts, throw them into the parking lot. That is going to stay active. So you can go back. I know we dropped a lot of links there to answer your questions, to articles and things like that. You can always access those, go back to that document and get those answers. So if anyone has any last thoughts or questions, we'll stay on for a few more minutes, but thank you so much for joining. Thank you, Chip, for all of the amazing information. I hope everyone is feeling a lot more comfortable with teaching this course next year. All right. Thank you, everyone. And we will hopefully see you at a workshop soon.